In an earlier video, I showed you this picture when I was talking about the definition of a hyperbola. And the idea was, in explaining that definition, if you take any generic point on the hyperbola anywhere, and you draw in this line segment from, say, the left-hand focus to that point, and then the line segment from the right-hand focus to that point, label, say, the length of this line segment D1, the length of this line segment D2. Turns out that D1 minus D2 is equal to a constant, let's call it K. If you need to, you can put in absolute values to make sure that this is a positive number, because we're just talking about distances here. Turns out K is equal to 2a. So if D1 is longer than D2, you can drop the absolute values and write D1 minus D2 is equal to 2a. Now, a is the distance from the center out to a vertex, just like it is for an ellipse. And we actually call C the distance from the center out to either focus point. And you can actually use the distance formula to find D1 and D2, manipulate it algebraically, and you can use that to get the standard form of a hyperbola that opens horizontally. And during that process, turns out that you'll figure out how C is related to A, and also to that value B. That's half the length of what's usually the shorter side of the box that we use to get the asymptotes of the hyperbola. So it turns out during the process of deriving the standard form of the equation for a hyperbola that opens horizontally, you'll end up with C squared is equal to A squared plus B squared. And that relationship will come in handy if we need the distance out to a focus point and we know what A is and we know what B is. Or we know two of these, A and C for instance, and we want to get B. One other thing you need to know, the line segment between the vertices, here's one vertex, here's the other vertex, that line segment is called the transverse axis of the hyperbola. And then the line segment that's perpendicular to the transverse axis that goes out a distance of B in either direction from the center, that line segment is called the conjugate axis of the hyperbola. So this distance from the center on out is B in either direction, this way as well. Okay, the standard equations centered at HK. So if you have a hyperbola centered at HK and it opens horizontally, then the way you adjust the formula when the center is 0, 0 is you just, instead of having an x squared, you have an x minus h squared. That shouldn't come as any big surprise. And then divided by a squared minus k, instead of y squared, y minus k quantity squared over b squared equals 1. That's if it opens horizontally as pictured here. And then interchange the roles of x minus h and y minus k if it opens vertically as pictured here. And then you get y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. And then as for the equations of the asymptotes, we know from a previous video that if the hyperbola opens horizontally, then the slope is either b over a or negative b over a. So to write both equations of both asymptotes all in one, you could take the slope to be plus or minus b over a, and then the left-hand side will be y minus k equals the slope plus or minus b over a times x minus h. So you've got two equations in the one there. And then if the hyperbola opens vertically, the slope of an asymptote is either a over b or negative a over b. So we'll go plus or minus a over b. And then the left-hand side is still y minus k, and then you have the slope times x minus h. And it's no big mystery where these equations come from. If you think about it, an asymptote like up here goes through the center. It either looks like that or like that. And let's say you want to find the equation of that line. Well, it goes through HK and it has slope b divided by a. Oh, all you have to do is use the point slope form of a line. Y minus y1 equals m times x minus x1, where x1, y1 is a point on the line, like HK, and m is the slope. So all you do is plug in. Oh, okay, we'll plug in k here, and we'll plug in h here, and we'll plug in either b over a if it's the line that goes up from left to right, or negative b over a if it's the line that goes down from left to right.